You can build a modern luxury cruise ship, a floating city, for about $1 billion. You can build a highly advanced, heavily armed warship for the Navy for roughly $2 billion. But building a huge block of raw steel, specifically designed to survive the coldest, most violently unfriendly environments on Earth, is proving to be a much more expensive problem. The United States government is currently facing a massive 60% cost increase to build its newest fleet of heavy icebreakers. The price tag to construct just 3 ships is now projected to hit $5.1 billion. The main reason for the ballooning budget is a lack of recent experience. The U.S. Coast Guard relies on a very old, small fleet, and they haven't built a brand new heavy icebreaker from scratch since 1976. The physical barrier standing in the way of these ships is multi-year Arctic sea ice. Most sea ice freezes during the winter and melts away, but multi-year ice survives multiple summer melting seasons. Over time, it gets packed down tightly, loses its salt, and hardens until it is almost as tough as solid concrete. This older ice can easily reach thicknesses of 10 to 15 feet. At that sheer density, the standard physics of naval navigation break down completely. The soaring costs and building delays exist because shipbuilders are trying to construct something they have long forgotten how to make. A heavy icebreaker operates nothing like a traditional boat. It is a highly specialized floating siege engine. Most people assume an icebreaker works like a snowplow on the front of a truck, slicing horizontally through the water. But hitting 10 feet of solid Arctic ice with a sharp, knife-like bow would stop the ship completely dead. Instead of a sharp edge, a heavy icebreaker features a blunt, rounded, spoon-shaped bow. When the ship meets a thick sheet of ice, it doesn't push straight forward. It uses its massive forward speed and spoon-shaped front end to physically slide up and over the edge of the frozen surface. Once the front of the ship is resting on top of the ice sheet, gravity takes over. Ice is incredibly strong when you squeeze it from the sides, but it is actually quite weak when you bend it downward. The enormous weight of the ship, often tens of thousands of tons, presses down and snaps the ice from above, breaking it into giant pieces. Surviving this constant crashing requires very specific material science. The normal steel used in everyday shipbuilding becomes extremely brittle when the temperature drops to 50 degrees below zero. If it gets hit hard enough in that freezing weather, standard steel will shatter into pieces just like glass. To survive the cold and the impacts, heavy icebreakers must be built with highly specialized low-temperature steel. The sides are covered in hour plating more than 2 inches thick, and the interior contains a very dense frame of steel ribs, specifically designed to absorb the continuous shock of ramming into the ice. Smashing downward through the ice is only the first step. Surviving the relentless, sticky friction of a frozen ocean is the final hurdle that drives the astronomical cost. The friction caused by 30,000 tons of steel grinding against the frozen ocean is enormous. Ice is remarkably sticky, and it constantly threatens to wedge the ship tightly in place, trapping it like a cork stuck in a bottle. To prevent this, engineers use high-pressure air bubbler systems. Giant air pumps blow pressurized air out of holes near the bottom of the hull. As these huge bubbles rush up to the surface, they create a slippery cushion of moving water and air between the steel and the ice. If the ship still gets wedged tightly and cannot move, it relies on advanced ballast tanks hidden inside the hull. Powerful pumps quickly move hundreds of tons of heavy water from tanks on the left side of the ship to tanks on the right side, and then back again. This rapid shifting of weight forces the massive vessel to violently rock back and forth, literally shaking itself free from the ice's grip. Propelling a giant vessel up onto a slab of solid ice requires a specialized application of force, immense turning power, or torque. If a normal diesel engine propeller hits underwater ice, the engine might stall, or the metal shaft could simply snap in half. The engineering workaround is to avoid turning the propellers with the engines directly. Instead, massive diesel engines or nuclear reactors act as generators to create electricity. That electricity powers massive electric motors that actually turn the propellers. An electric motor can provide its maximum pushing power even when turning very slowly, relentlessly chewing through the ice without stalling. When you package the cold weather steel, the air bubblers, the rocking water tanks, and that massive electric torque into one single vessel, you get a highly complex machine. Very few nations in the world have the money or the technical skills required to build one. The barrier to entry for this kind of engineering is so high that the United States recently signed a special agreement called the Ice Pact with Canada and Finland. They're actively sharing knowledge, essentially trying to help each other relearn how to build these vessels faster. While the United States struggles to field just 3 of these ships, Russia operates an active fleet of over 40 icebreakers. They also hold an exclusive engineering advantage. Russia is the only country on Earth that operates a fleet of nuclear-powered icebreakers. With nuclear power, these ships can drive straight into the darkest, coldest depths of the Arctic winter and ruthlessly smash through the ice for months at a time without ever stopping for fuel. This map displays the massive geographic prize that justifies Russia's investment, the Northern Sea route. This global shortcut across the top of the world cuts transit time for cargo ships traveling between Europe and Asia by up to 40% compared to traditional southern canals. To the Russian economy, this frozen expanse serves as a critical national highway. Billions of dollars in exports, specifically liquid natural gas and oil pulled from the northern lands, rely entirely on traversing this frozen ocean all year long. Because Russia owns the waters around this route and possesses the only fleet capable of keeping it completely clear of ice, they operate the entire ocean like a giant toll booth. If an international cargo ship wants to use the shortcut, they have to pay a large fee for a Russian icebreaker to clear the path and lead the way safely. Maintaining the only fleet capable of taming the ice gives Russia the power to dictate the terms of trade across the top of the world. In the Arctic, geopolitical control is bought with specialized steel and nuclear power.